Hey students, this is lesson 11.5. We're going to be finding the volumes of pyramids and cones. Go ahead and do the vocabulary for a review here, and I'll check back with you. Hey students, here's the properties we're going to use, but to help you understand these a little bit better, I'm going to show you a quick video here.
What I have here is a pyramid whose base area, their base areas are identical. Identical base areas, you'll notice that the two bases are the exact same size, and the height of the two objects is exactly the same. So the base area is the same, the heights are the same, just as in our example with the blocks. So what we want to do is find out how many of these pyramids of the same base area and height fit into the equivalent prism. Well, if we pour this bowl and dump it in, there's one. Pour this bowl, dump it in, there's two. Pour the pyramid bowl, dump it into the prism, there is three. So it appears that the pyramid holds exactly 1/3 of what the prism does. That agrees with our 0.333 in the ratio column. But, go ahead and pour that back. That is with a square pyramid and a square prism. What if we take a triangular prism and a triangular pyramid? Again, base areas are identical. Heights, you'll notice, the heights are the same. And we will see if this same relationship holds. We will pour a triangle pyramid into the triangular prism. 1, 2, and 3. The reason that was probably a little bit high is because I poured this up past the base. But you can see that it is a 3-to-1 ratio. Okay? That leads us to this formula. Volume of a pyramid is equal to base times height, just like the mother formula. However, we want 1/3 of it. So if a prism goes to a point, we call it a pyramid, the area or the volume formula is 1/3 of what it would have been had it gone straight up. But is that true with this object? We have a cylinder and a cone. Same base area, identical heights. Does this hold true for cones and cylinders as well? Let's find out. One cone into the cylinder, two cones into the cylinder, and three cones into the cylinder. And yes, it appears that anything that comes to a point contains exactly 1/3 of what it would have contained had it gone straight up. So we could.
All right students, so that's a demonstration of these formulas. Now we're going to go ahead and use these formulas. So we just found out that the volume of a pyramid is 1/3 the volume of the prism that has the same base area and height. So we have that here, 1/3. Okay, the volume of a cone is also 1/3 of the base area times the height. And with the cone, we're going to, of course, have a circular base, so we're going to use pi r squared for that. And so, but for both of them, we can just think of 1/3 times base area times height. It's just the base area of a cone is pi r squared. All right, so to use that idea, so the pyramids are big square pyramids, and we can now find the volume of those by using these formulas. The volume equals 1/3 the base area times the height. And if we look over here, we have a square base, so our base area is going to be 755 squared. And our height is given as 485, and that's the perpendicular line from the base to the point. So we're going to do 1/3 times 755.5 squared times 485. And when I do that, I am going to get about 92,276,140 cubic feet. All right, go ahead, you can try that here. All right, problem 2. What is the volume in cubic yards of this square pyramid with when you're given the slant height? So the only thing different here is we're still going to use the volume equals 1/3 the base area times the height, but we're going to have to calculate the height, and the height is a perpendicular segment there, and the base of this triangle I just drew is 9, and so the height is equal to, using Pythagorean's theorem, we're going to do the hypotenuse squared minus the given length squared, which gives us the square root of 144, which is 12. So our height is 12. And then our base area is a square here, so we're going to have 18 squared, which is 324. And I'm going to substitute those in, so I'm going to get 1/3 times 324 times 12. And that's equal to 1,296 cubic yards. All right, I'll let you go ahead and try that. All right, problem 3. About how many cubic centimeters of water does the paper drinking cup hold? All right, so this is a cone, and our cone volume is again 1/3 base area times height. But more specifically, our base is a circle, so we're going to do pi r squared times height. So I need to know a couple things. I need to know r, so let's draw that in. R is 4 centimeters. And I also need to know the height, and here it appears that we're given the slant height of 11, so we're going to have to do a little Pythagorean theorem work here, and do 11 squared minus 4 squared. And I'm just going to leave that as 105, because that is not a perfect square, so, and then substitute that in for the height. So now I'm going to do 1/3 times pi times my radius squared, which is 4 squared, is 16. And times my height, which is the square root of 105. And then I'll just approximate that. And I get about 172 cubic centimeters. And just a quick note of information here. 1 cubic centimeter is equal to 1 milliliter. So since we're talking about water, we can say that this thing holds about 172 milliliters. All right. Go ahead, you can try that. All right, here again we have the volume of a cone. This is an oblique cone, and but the way you find the volume is the same. it's 1/3 pi r squared h. So in this one, we can just substitute right in. I think we're given pretty much the information we need. The radius, of course, is half of the diameter given, so that's 8. We need to square that, so that's 64. And then the height is 15, because that's a perpendicular height from the base to the top. And then I'm just going to simplify that. And it says we need to give it in terms of pi. So 1/3 times 64 times 15 is 320 pi. And then approximate that to the nearest cubic inch. That would be 1,005 cubic inches. All right, you can try that. All right, lesson check. What is the error here? So a student thought that a square pyramid with base edges 13 and 10 would have the same volume as a cone with a diameter of 13 and a height of 10. So we'll just check that out and see. All right, and that's the end of the video. I'll see you tomorrow.